Hi, I'm Katya and my project partner is Marilio. The idea for our project comes from our love of trains, especially for me since I'm used to traveling sometimes for days at a time to see my grandmother in Novosibirsk. We designed an automatic railway gate control system using an infrared circuit. Although not everything we attempted worked instantaneously, since we are both beginners, we consider our project a success and it works. Thank you. We used a circuit called push-pull amplifier to drive the speakers. This circuit expects alternating voltage from +7 to -7 volts, which we provided by an outside power source. The input signal that we send to the speakers is a combination of various frequencies programmed on the Arduino microcontroller. The original signal from the Arduino is a square wave created by pulse width modulation. Then we send it through a 100 microfarad capacitor to create an alternating voltage. The four diodes seen on the schematics smooth the signal, which then goes through either a tip 120 or tip 125 transistors to drive the speakers. Arduino has a limited voltage supply of 5 volts, which was not enough to power the circuit. Power supply had to be used to correct this issue, otherwise the sound wasn't loud enough. The LCD display is a visual addition to show our project's title, UCLA Express. The display has 16 pins to display 16 characters per row with a total of 2 rows and requires multiple connections to Arduino as well as inclusion of liquid crystal library in our code. It is connected to a potentiometer which allows to adjust the brightness. Things we learned in this project. We improved our programming, troubleshooting, wiring, and organizing skills. Though there's still room for improvement, there are a few things that we would have done if we had more time, such as a train horn, as well as a sound sensor to set up a train moving to a clap. Thank you very much.
And the way this circuit works is this LED emits light, and when the detector reads this light or observes it, there's a current running through it, which it then sends to the pin 4 of the Arduino. And when the light is blocked from the LED and it no longer reaches the IR detector, it sends a voltage drop through the pin 4, and the Arduino now reads 0 volts, and it causes the Arduino to send a signal to our servo motor when the voltage changes. Here we have the schematic of the servo motor connected to pin 9 of the Arduino. As mentioned before, the servo motor is only operated when there is a voltage drop in the infrared circuit. That is when the infrared beam is broken. The code is then executed by the Arduino to move the servo motor using pulse width modulation. Pulse width modulation is a digital wave with discrete values and time generated by the Arduino. Due to the way the signal is processed by the server, it causes movement out of the servo motor. The signal can be manipulated to change the speed of the gate and the range of motion.